Hello, everyone. I am Aram Manasselyan from Mathematical Computations team of Wolfram Research. My main work at Wolfram is devoted to symbolic solutions of differential equations and improvements in dissolve function. But currently, I'm working also on another interesting and exciting topic. I'm working on a new Wolfram textbook about partial differential equations. And today, during this talk, my colleague Tigran Ishkhanyan and I will speak about two new Wolfram textbooks. I will introduce the book Introduction to Partial Differential Equations, and Tigran will speak about the book Introduction to Special Functions. I hope you all know that currently there are many free interactive mathematical courses in Wolfram U webpage. Here you can see the list of all of that mathematical courses, but recently we started to transform some of these courses also into books. And the first book in this series, entitled Introduction to Calculus, is already published, and currently it is available for purchase in Wolfram webpage and also on Amazon. And I think this book project was quite successful, so we decided to continue and to publish more books in this series. So we have two approaches here. First approach is to choose one of these existing courses and to transform it into a book, similar to the calculus case. And second approach is to write a new book on a new topic and then prepare a course on the base of the book. And in my case of partial differential equations, we choose second approach. So currently I am working on a new book, Introduction to Partial Differential Equations. This book will give a general introduction to partial differential equations and their solving methods. Also, it will cover all main topics of partial differential equations, such as heat equation, wave equation, Laplace equation, also some important and famous PDEs, like Schrödinger equation, Maxwell equations, Black-Scholes equation, Navier-Stokes equations, and more will be discussed here in detail, together with many application examples and exercises. Here you can see the plan of the book. The book will contain 8 chapters, and each chapter in its turn will contain from 3 to 4 lessons. First chapter of the book will be an introduction and fundamentals of partial differential equations. Then second chapter will be about linear and nonlinear first order partial differential equations and their applications. Chapters 3, 4, and 5 will be about second order linear partial differential equations such as heat equation, wave equation, and Laplace equation. In chapter 6, higher order and PDEs with higher orders and higher dimensions will be discussed. Chapter 7 will be about 4 famous PDEs, Black-Scholes, Schrödinger, Maxwell, and Navier-Stokes. And finally, chapter 8 will summarize entire book. The book is not finished yet. I'm still working. We are still working on it. All titles which are in blue color here are ready now, and all titles which are black is not finished, so we are still working on them. We are in progress. But in order to demonstrate the structure of individual chapters of the book, let's have a look to one of already ready chapters. For example, let's go to chapter 3, which is about the heat equation. This chapter has 3 lessons in it. The first lesson is Introduction to the Heat Equation. Here we have a small text about heat equation and why it is important. Then we have a small section about the history of heat equation, when and why it was created, etc. Then we have another section about derivation of heat equation and using energy conservation principle. And next section is about different forms of heat equation and their physical meanings. In each section, we have also some examples, solved examples, and at the end of the lesson, we have a short summary and exercises followed by solutions. Next lesson of this chapter is about solving the heat equation. Here we discuss several different methods how we can solve heat equation, such as the method of separation of variables, Fourier transform method, Laplace transform method, and also how it is possible to transform harder versions of heat equation into simpler one and to solve. Again, in each section, there are a few solved examples, and at the end, we have a short summary and exercises. And finally, the last section of this chapter is about applications of heat equation. Here we discuss some real-world physical problems and systems which can be modeled using heat equation. For example, heat transfer in insulated rod, or heat transfer when we have heat source, or diffusion problems, and also one problem from economics in which we have which can be modeled using an equation which is similar to heat equation. And again, at the end, we have a short summary, some examples and exercises followed by solutions. And I want to say that all other chapters have or will have similar structure. We will give an introduction to the topic, then solving methods, and then applications. Next question is, what is the difference between this book and other PDE textbook? First of all, I want to say that in this book, we give general introduction to partial differential equations and their solving methods. So we don't go deep into complicated theories of PDEs and also theorems and proofs. Instead, we believe that we give enough information which will be enough for students of engineering and science departments to understand what is the partial differential equation, how they can solve it, and also how they can use it in their application examples. And again, I want to say that the book is unfinished yet, and we are still working on it. I hope that we will finish writing by the end of this year, and I hope that the book and also corresponding Wolfram U course on the base of this book will be available during next year. So I think I should stop here to let my colleague Tigran also to speak about his book about special functions. Thank you for your attention. If you have any questions, I will be happy to answer them during Q&A session after the talk. Thanks.
Okay, great. Thank you, Aram. Hello, everyone. My name is Tigran Ishkhanyan, and for the last few years, I was working on special functions and differential equations here at Wolfram Research. And currently, I'm working on a book and Wolfram U course called Introduction to Special Functions. So a bit of motivation why we need such a book. In fact, special functions are a class of mathematical functions that arise in different areas of science, so while solving differential equations, integral equations, and so on. And special functions have their origins in the study from different problems coming from 18th and 19th centuries. And here I have pictures of very well-known scientists of that period. And also, the scientists worked on special functions theory, of course. And now we have named functions like Bessel function, Airy function, Gauss function, and others. And all these functions, all the special functions, played a crucial key role in the development of science last centuries. So this is a bit of history. So why special functions are important? Because they have applications in various fields of science, in applied sciences, engineering, mathematics, and so on. And also nowadays, they appear in different interdisciplinary fields, such as quantum mechanics, mathematical biology, and others. And also, understanding these special functions will allow researchers to tackle a wide range of problems. And also, here I'd like to stress that special functions, they are continuously being studied, extended. The list of functions is being extended. We have new functions that should be implemented in different computer algebra systems and so on. So in general, knowing about special functions, knowing how to work them, knowing the differential equations that they solve will be very profitable for students and scientists. And a bit about the book. So in fact, if one is interested in special functions, and you can find classical textbooks on this topic. So here I am giving 3 examples of such books, like the higher transcendental functions that are from the middle of 20th century, the Abramovitz-Stigen Handbook of Mathematical Functions, which is a huge book containing a lot of formulas, a lot of derivations, and so on. And the most, say, updated special functions book is the NIST Handbook of Mathematical Functions, which is coming, I think, from 2010 or something like that. Also, in the context of Wolfram technologies, we have 2 very nice resources that are also about mathematical functions and special functions. The first one is the Wolfram Math World, which is covering almost all the special functions, giving some basic information, some nice formulas, and some applications using Wolfram language. The second one is called Wolfram Mathematical Functions Site, which is a huge library of special functions, having thousands of formulas about them. However, the point here is that all these sources are for in-depth study of the theory, special functions, because they are focusing on different formulas, properties, derivation of these formulas, and so on. So they are like, one can use the sources if going really deep into the study. While in contrast with that, in the book that I'm working on right now, the Introduction to Special Functions, we have tried to incorporate most of the special functions, but in a very interactive way. In the book, we are using Wolfram technologies, and also we try to limit the given information, the amount of given information, such that the book is planned to be a very gentle introduction to the topic, which is a key feature of that book. So first, it's very interactive. Second, it's using Wolfram language, and third, it's a gentle introduction to the topic. Let's take a look on the contents of the book. So here we have 10 sections, 10 chapters, and in total 30 sections. And here we see that the first part is giving a general information about special functions, some review of mathematical operations from calculus, and also discussing the differential equations and their main features. Then we are turning to named special functions. The first group is gamma-related functions. Here we have Euler's gamma function, the beta function, and the gamma function. Then we're covering the special integrals, which are like error function, exponential integral, Fresnel functions, and trigonometric integrals. Then the orthogonal polynomials group is coming. In the book, we cover Legendre polynomials, Hermite, Laguerre, Chebyshev polynomials, after which we are turning to Bessel-related functions, covering the Bessel functions, well-known famous, Kelvin, Hankel, Struve functions, and as well as Airy functions, talking about Airy functions. After finishing the Bessel-related functions, we are going to hypergeometric functions, covering the generalized hypergeometric series and function, the PFQ function, 2f1 Gauss hypergeometric function, and the 1f1 Kummer hypergeometric function. After that, we're talking a bit about the elliptic functions and integrals, trying to give very interesting information, but without details, because the topic is very huge, about Jacobi elliptic functions, Weierstrass functions, and elliptic integrals. And after that, we are shifting to advanced special functions, which and covering here the zeta function, Matthew and spheroidal functions, and the class of functions, the Hohen functions, 10 functions. And finally, we are covering the superfunctions, so-called superfunctions, speaking about multivariate hypergeometrics and Appel functions, and say finishing the book with two monster functions. The first one is called Mayer's G function. The second one is called Fox H function. And finally, giving some summary of that, of all the covered topics. So this is the plan of the book. Now for demonstration, let's take a look on a couple of chapters from this book. So the first one is the beginning of the book. It's about what is a special function. Here we're giving a small brief introduction, and then in these subchapters covering like what is an elementary function, why we should turn from elementary to special functions, covering the main special functions, giving some motivation, why to study special functions, and of course, a brief review of literature, what we have, which are the sources that one can use to go deep into the theory. Also giving some, in all these subchapters, we have like nice examples, trying to cover all the developments that we have in Wolfram language connected with special functions. And we are like finishing the chapter with some summary and giving basic references. So this is the first chapter, which is opening the book. Now let's take a look on chapter 17, which is about Airy functions. And this is more or less a standard chapter with standard structure. So while speaking about different special functions in each of the like 27 chapters, we are starting with a brief introduction with some information about applications, mentioning the names of the functions, the notations of the functions, giving some basic information and some plot of that. And after that, we have some information about the differential equations with interactive examples using Wolfram language, some plots. Another standard chapter is about properties. So this chapter is available in all this subchapter is available on the chapters of the book. Here we are giving some series representations, if they are some asymptotics, another information if it's needed, and giving some main features, covering them, integration, and so on. Also, if it's possible, if it's available, we have some relations to other functions. As an example of Airy functions, they are heavily related to Bessel functions. So, of course, we are covering all this stuff. Also, we have always a subchapter called differentiation, because this information might be very useful for scientists. So in the case of Airy functions, we have two more functions that are called Airy AI prime and Airy BI prime. And these are more general functions, more complex functions. So mentioning them, giving the differential equations that they solve. And every chapter of the book is closed with an applications subchapter, where we're first of all describing the applications and also giving some real-world applications, like here the Schrödinger equation in a linear potential, which is solved by airy functions, some applications from statistics and probability theory, and others if they let mathematical applications are possible, and so on. And the chapters are closed with a small summary having from 5 to 7 lines and some exercises, which will then go from the book to the upcoming course, Wolfram U course. And the exercises also have their solutions, which are also available here, like this one. Okay, so this was just to demonstrate how the chapters are made. And now let's go to the end of the presentation. So now me and Aram, my colleague, we are working on 2 books, Introduction to Partial Differential Equations and Introduction to Special Functions. These books are planned to be gentle introductions to the topics. Also, we'll make Wolfram U courses for them. These books and courses will enrich the mathematical series books made by Wolfram Media and Wolfram University. And they will be very useful for students and other researchers that want to have some general information about the topic. And as a final words, I would like to mention one more book, which is Introduction to Linear Algebra, that is already ready and will be published soon, I hope. So that's all. Thank you, and we are now ready to answer some questions if there are any.
I can see a few questions here. First question by Dave G. When one of his books is bought on Amazon, will the Wolfram language code be available somewhere? If the question is about code which is necessary for solving examples and equations, I think all of them will be available in the book. So we can use them to solve the equation, also we can try to modify and to solve some other examples. Next question, which would you recommend studying first, the book or the corresponding Wolfram U course? My opinion that you should do both. It will be more useful to look at the course and also have book with you. And next question, do you plan to have ebook versions that are not Kindle ebooks? Of course, this is a question to book production team, but I think there should be ebook version, also paperback version, and I hope also a version for Kindle ebooks.
Just wanted to say that all the chapters that we are working on now, they are interactive, so you can like get them in a Wolfram language notebook. It's a Wolfram language notebook, and then you can play with the examples, modify them, solve some equations, plot the solutions, and so on. I think there is one more question from Dave G, which is repeating the same question. So if you were learning this material, would you read the book first, or would you take the Wolfram U course first? Aram, my colleague Aram already said that I think they are like equivalent to each other, but of course the book will contain a bit more information than the course. So I don't think that there is an answer, like a straight answer to this question. It depends what you like more, reading a book or learning some courses.
Okay, if there aren't any new questions, I think we can close this session. Thanks.